John, man, that really summarizes exactly why I love the Socratic method and Socratic seminars. It puts you in an uncomfortable position of actually having to think like a real human. It's crazy. Just the aspect to ask good questions is very difficult. And of course, answering good questions is also very difficult. So I totally get that you were uncomfortable. That's exactly where you want to be.
Hello, fellow Bitcoiners. I'm John Chanot, and welcome to episode 12 of the Bitcoin Path podcast. This is a show where we have deeper conversations about Bitcoin and self-sovereignty, about how this new magic internet money is changing the world and changing ourselves at the same time. In this episode, I'm excited to share with you session number 4 with Max Hillebrand of the Cosmic Deep Dive online event. This was an interactive event that took place on December 12th and the 13th of 2020. It was 2 full days of back-to-back immersive Bitcoin educational webinars with some of the leading educators in the space. We had tremendous feedback from everyone who attended and just had a great time all around. Keep an eye out for more events like this one coming up at thebitcoinpath.com. Also, you can find Max on Twitter with the handle @HillebrandMax and check out his website towardsliberty.com. With that, let's get into this episode. I'm really excited to welcome all of you to session 4 of the Cosmic Deep Dive online event, and I'm thrilled to introduce Max Hillebrand for today's session. And just a quick introduction to Max. Max is an open source entrepreneur who is supporting several Bitcoin projects, and he builds tools for sovereign individuals to defend their property rights, liberties, and privacy. He has he's shared his knowledge and experience in several free YouTube videos that have helped a lot of people to integrate into the new digital realm, so to speak. And he has an in-depth understanding of sound monetary economics and Bitcoin and its particular value proposition of immutable scarcity in this age of anarchy and money. Max is just, in my experience, Max is an extremely passionate man who cares deeply about communicating and putting into practice the fundamental principles and tools of freedom that are available to us at this time. I'm really grateful for Max coming on and sharing with us today. His really unique format set up for today, so I'm really excited to introduce him. Max, I'll let you take it from here.
Well, thank you very much, John, for that kind introduction. I'm really looking forward to this event. I really like these, small-scale, very interactive sessions. This Cosmic Deep Dive, I think, has provided a great opportunity here for attendees to speak and have a dialogue and actually have a conversation with some of the awesome minds in the Bitcoin space. So great sessions before and a couple more great sessions to come. So it's nice here to start off the second day. So a bit to the actual method that we're going to use here, because this is not going to be a frontal presentation. I don't just want to blabber at you right now, specifically because there are people here in an interactive format. So I would love to have a conversation here with everyone attending. So please, if you're in the call right now, take that opportunity, speak up. I will be asking you questions personally addressed to your name. And I don't necessarily expect a correct and perfect answer, but I do expect you to reason about it and to think about the question and what you actually think for yourself. Right? This is really about truth discovery. Yes, I think let's just get started with one of the, of course, first questions that come to mind here. What are the actual goals of the Socratic seminar? What do you think, Eric?
Can you guys hear me?
I
think the goals of the Socratic seminar are to build understanding and to debate.
Okay, actually, very nice. I realized there are two Erics in the
Yeah,
room.
we got
Very
two
cool.
Erics.
So that's going to be fun, but we'll figure it out. So yes, to foster a conversation and understanding, right? That's actually pretty good, Eric. But Eric Kaysen, what do you think?
I would agree with that. In addition to, I'd say, challenging one another to have a more in-depth exploration around topics that perhaps we didn't originally think related to what we were talking to, but through discussion, we can make a deeper discovery that allows for us to understand those connections.
Yeah, that's a very interesting point, right? Because we can collaborate here with other people who have other unique insights on a topic, and we can actually ask them about their points of view on whatever the subject matter is, and that helps us to actually understand it ourselves, right? And to get a more deeper and broader view of the topic. So yeah, great points, Eric. Sad, what do you think? What are the main goals of the Socratic seminar?
Sorry, Set is just my desktop account. I'm just up and about mobile on
I see,
Eric as well.
Okay. Now I get it. Perfect. And then we got the name discrepancy also. I will call you Sed in Eric case, and I will call you Eric.
Awesome. Cool.
Okay, cool. So yeah, I think that's very nice. One thing that I would also like to mention for this for the seminar really is the importance of asking questions, because we don't really know a bunch of things, right? There's a bunch of aspects that you, quite frankly, don't understand. So we ought to have a million questions in mind, and it's so what comes to mind first is also to ask a question about the question, right? Does this question even make sense, right? So, for example, if for this session, the main overarching question is, what are the entrepreneurial use cases and business models possible with the Taproot technology? So, I know just a broad question to start us out with. What do you guys think about this question? Is it important? Is it relevant? What do you think, Herman?
Can you hear me? Hello, Max.
Loud and clear.
Hello. I mean, for me, I think it's the art of conversation in general. I mean, the quality of question gives you a better quality of answer, then so you move from there. That's what it is for me. That's what Socrates did for my development. So.
Yeah, right. If you ask stupid questions, you're gonna get stupid answers.
So working on the quality of questions definitely helps a lot to move forward and find the truth, maybe as well.
Yeah, right. It's a starting point of your thinking. If you mess up with the question, then you can't really come up with truth, or you're gonna have a lot of different hurdles here. Yeah, Eric, what do you think specifically about this question, like the entrepreneurial use cases and business models with Taproot? Do you think this is a meaningful alley to go down?
I do. I think it allows for us an exploration of some of, sort of what the future of Bitcoin offers, and perhaps some of the entrepreneurial models that haven't been fully considered at this point in time. And I think that there's what's the word I want? There's a lot of space where people haven't necessarily applied a thought towards, like utilizing these new features that will be premiering in Bitcoin will be able to, perhaps make some sort of microtransaction easier. Maybe there's some way to do M of N signatures in a way that's unique to allow for quorums to, allocate capital to larger things. So yeah, I think it's an interesting question to consider, into the future for kind of what some of the things that we're going to see over the next 5 years in the development of Bitcoin will be.
Yeah, good points, right? So this is a very new technology, and all of a sudden we have a bunch of problems that we can solve potentially with this technology. But because it's so new, not many people have even discovered that there are problems, let alone how to solve them with that technology. So yeah, that's very true, right? So when we venture out here into the unknown and actually discover the answers to these questions, how we can use Taproot as an entrepreneur, then this enables us to strive forward and discover something new. Good points. What do you think, Sed?
I mean, I think everyone's made good points. I think that the possibilities with Taproot are still kind of beyond the questions that I have. So I'm really curious where the conversation goes. I think there's a lot to be had here, and I'm just not sure what my questions would be regarding Taproot. My understanding of Taproot is kind of just starting to build out, and I'm really kind of fascinated by it, but I haven't developed my own questions yet.
No, but that's very important, right? That's very good that you bring this up, because we have a very complex question here, right? What are entrepreneurial use cases of Taproot? Well, what the fuck is Taproot, right? So before we can even answer that overlying question, we first need to answer the question of what is actually Taproot, right? So that's very good that you pointed out. And it's important that we go through this here today, because right, if we don't really know what we're dealing with, how do we know how to apply this technology to solve problems? So yeah,
Right.
very, very good point.
I would second that with Cedric. I think I have a very basic understanding of Taproot, but definitely looking forward to understanding it deeper in order to further extrapolate what potential problems it could solve. So sounds great.
Okay, nice. So there are some potential problems, right? And you're not even yet sure what exactly the problems are, right? But eager to find out where the actual pain points are, right? And how we can actually fix that. So I think that's a very interesting path to go down, right? So what are actually the current problems? Like, in what area does the current Bitcoin protocol have some issues? So yeah, that as the question, Eric, Sed,
Sure.
you have your hand up. What do you think?
Yeah, well, so yeah, I'm both interested in what problems Taproot solves, but also what, kind of back to what we were talking about earlier, what solutions it might provide, especially around maybe things around social media and podcasting, like what Adam Curry's doing, and how it integrates, I guess, with Lightning, is kind of what I'm really interested in, beyond just how it works. Yeah.
Yeah, so that's another really important question, right? How does Taproot improve the Lightning Network specifically, right? So how can we use this new modular technology in a broader system, and what can we then do? And actually, right, what are the solutions? Not just thinking about the problems, but also how do we actually fix them? And specifically here, right, I would add that it's with an entrepreneurial mindset, right? So we actually want to solve a problem for our customers, right, in order that they give us money. That's basically the gist of it. Yes, what do you think, Seth?
Yeah, that's what I'm really excited about, and just really hearing more, I guess, about how Taproot works, what are the benefits of it, what does it fix, and then what can we do with it beyond fixing things.
Yeah, okay. By the way, Seth, I see that your hand is still raised, so maybe you have to unraise it after you made your point. Okay, so let's get actually into it, right? So let's start out on some basics, and then actually work ourselves deeper and deeper into the problem. So I think a nice way to start this out with is the question: who can spend a Bitcoin? Right? What do you think? How do we actually figure that out? Who any specific Bitcoin can be spent by? Herman, what do you think?
I think everybody can spend Bitcoin who has got the hardware and the software. You can spend Bitcoin from peer-to-peer transactions, and yeah, you just have to have the basics. That's the way I understand it, and that's the strength, and that's what I like about it, because there's no parasite in the middle.
Yeah. So basically, to summarize, what you're saying is that anyone can spend Bitcoin as long as he has the technical capabilities, right? The right hardware, computer, the right software, Bitcoin wallet, and a Bitcoin full node. But other than some technical requirements, there is no permission needed from any other human, right? You don't have to necessarily like ask someone else to do this for you. You can do it all by yourself. Yeah, that's a very powerful aspect.
It's very important for me as well.
Yeah, that's for sure the key aspect of Bitcoin, right? John, what do you think? Who can spend Bitcoin, or who can spend a Bitcoin?
Yeah, I'd say more specifically, it would be the person who has control over that particular set of unspent transaction outputs. Like, the one who has the private keys.
Yeah, that's nice. That's nice. So you mentioned unspent transaction outputs. What are these actually?
So from my understanding, it's a particular group of transactions that well, or yeah, I'm not gonna be able to explain it very well. A group
No,
of what's that?
it's a difficult concept. So
Yeah,
maybe let's split that apart. So
Sure.
we said unspent transaction output, right? So let's start with transaction, right? That's one part of the term that we want to describe. So what is a transaction?
Yeah, and it's an exchange between two individuals. On the
mhm.
Bitcoin network, I suppose it's an exchange of information.
Okay, so an exchange of information and among two individuals. So can it be more than two individuals, or is it limited to these two?
No, it can be more.
Uh-huh, uh-huh.
I don't know about on Bitcoin, but I know in any kind of transaction there could be in an abstract way there could be multiple parties transacting together.
Yeah, okay, that's really interesting, right?
Mhm.
And that's very important in Bitcoin. A transaction is not just by one individual. Transaction can be by multiple individuals in a very complex way, right? So that's very good that you point this out. A transaction is not just singular by one user. It can be, but it doesn't have to be, right?
Mhm.
That's very important. But let's dive a bit more deeper. What are actually the individual parts of a transaction? Eric, what do you think? How would you explain the parts of a Bitcoin transaction?
Well, that's a good question. Let's see if I can't not put my foot in my mouth on this one. So the various parts of the transaction, I'd say you would have whoever's the signer for the UTXOs on the transactions and how that's going to aggregate into the next transaction. Let's see what other components. There's where you're sending it to, the receiver's address that they have, which is their public key. Yeah, that's all I got off the top of my head.
No, man, that's
covers
pretty
some of
good.
it.
That's pretty good. Right. So you highlighted the two important parts of a transaction. It has a signature to it, right, and it has a destination address to it. So let's dive a bit deeper down first on that one side. What does it actually mean to have a signature on this transaction? So what is on this input side of a transaction? Herman, how would you put it? Herman, I see you're still muted, but you turned on your camera.
Is that better?
Yes, now you're coming.
Yeah, I have to put the address in where I send it to. Of course, I need my private keys to sign the transaction as a fingerprint, sort of, to send it off. And I don't need, the value. I mean, there has to be a value as well. So I need what I spend, because I'm gonna spend out what I spend, and what I not spend, because I'm creating a new like mailbox. When it comes back, I've got the unspent in my, I've got the unspent, the UTXO again on my side, which I've got the proper rights, and the other one, it's not really coins we're talking about. We're just talking about figures and numbers and mathematics. They stay with whoever I send it to. That's the way I understand it.
No, that's really spot on. Absolutely. So right here, what you brought up, there's a value that we attach in the input, right? There's a reference to what Bitcoin we actually spent, right? And here in this section of the transaction, in this input, this is actually where we spend a coin. We put a previously unspent transaction coin into this input of a transaction, right? And this basically says that, hey, I want to spend this coin, right? But what's that also said is that this is not enough. Right? It's not enough to just provide a reference to this coin. You also need to provide a signature, right? So the signature is a very important part of a transaction. Eric, Kaysen, what do you think? Or how would you explain what specifically that signature actually is?
I would say what that signature actually is it's the proof of the control of that private key, and it's utilizing the private key explicitly to signal to the network that you control whatever unspent transaction outputs are within that. In addition to, you could just sign for the specific address, even if it didn't have keys in it, perhaps to prove previous transaction ownership or something like that.
Okay, that's a very good point. Right, so signature is how you claimed, or how you said, a proof of control over a private key. Right, maybe a bit of a different way to look at this is proof of knowledge of a private key. Right, you know a private key, and then you can calculate the signature. Right, that's how basic private public key cryptography works. So that's very good, right? But is this or in a Bitcoin transaction? For the signature part, is it only one signature, or can there be more to this proof to make a transaction valid? Herman, what do you think? What other things can be here to prove in a valid signature?
I mean, as in when I've got a multi-sig transaction and I patch the transactions, or I mix them, or I've got a paywall. I mean, I've got so many possibilities to sign the transactions. I mean, everybody can put them all together, and then they are diverted into different ledgers, where they're supposed to go.
Yeah, you bring up one good example. That's multi-signatures. Right here, it's not just one private key that has to be proven knowledge of. There are multiple. Right, we call this a M of n multi-signatures. So there are 9 or n public keys, whatever number this is. Let's say 3 public keys, and for the transaction to be valid, there has to be at least 2 signatures out of 2 of the 3 private keys, and only then the transaction is valid. Right, so here we already see that this proof of validity of a transaction on the input side actually can be more than just a single signature. Eric, what do you think? Are there any other ways that we can lock up a spending condition of a coin?
Sorry, one sec. Is there a limit to the number of signatures that could be required for a transaction?
Oh, that's a really good question. Right. Now let's look at it from that way. What is the actual, or what is the resource cost that we have here when we do these validations of a transaction spending condition? What is the actual resource that we consume here, John?
Can you repeat the question? I'm sorry.
Like when we have smaller or more elaborate spending conditions, right? What is what resource do we use differently of? If we have just one public key or multiple public keys, for example, what do we consume more?
Just more information, more data.
Exactly, right? It's more data. So this means if we have a transaction with many participants, many public keys and so on, then the data size, the bits of this transaction will be larger, right? And where in the Bitcoin network, when we pay for the confirmation of a transaction, right? Which resource is calculated for this total sum that we pay to the miner?
The transaction fee. So basically the more signatures, the more data, the higher the transaction fee will be, right?
Precisely. That's exactly the logical chain, right? In the current model, the more signatures we have, the more signatures we have, the more data, or let's say the more users we have collaborating in this transaction, the more data we have, the more expensive it is, right? That's a very important thing that you just highlighted here, right? And this is a big downside of the current Bitcoin system, right? Because the more elaborate your script is, and the script is this definition of who can spend the coin, right? The more complex this is, the longer it gets. and then the more data you have to reveal on chain to get it confirmed, and therefore it's more expensive. It's one of the big downsides of the current protocol. Let's keep that in mind. So
Awesome.
let's then. So to sum up, on the input side, right, we have a reference to which coin we're spending, and we have a proof that we actually certify or that we actually keep that we are validated to spend this transaction. Let's put it as this for now. But we have not yet looked on the output side, right? So what is actually on the output of a transaction? Herman, how would you explain that?
What's on the output side of the transaction? I think everything's going out. I clear out my konto. I'm gonna clear it out, and some things the receiver gets, and the rest comes back onto on the transaction side. You know, on that block. It's written in there.
Yeah. One very important and good point here. You spent the entire value, right? Everything goes out. So if you have the inputs, right, and these inputs are worth 10 Bitcoin, then the outputs also got to have the entire 10 Bitcoin, right? That's a very good point. But there is
a new konto all the time. So you never have the same. Like in the old banking system, you have got your, what do you call it, konto in English?
Account.
An account. So you always have got a new account then. That's what's created.
Yeah, exactly. Very, very good point, right? You can always create a new account basically and receive money on there in the output of a transaction. But what specifically is actually that account, and how do we call that in the Bitcoin space?
What's the ledger or no,
the wallet?
The wallet, right on. That manages the account.
Okay, so a wallet manages the account, right? That's correct. I agree with that. But that does not really explain what the account is basically. And I would even say that's for now not even the more standard terminology. The account is not really the word to use. Specifically, it's an address in the Bitcoin terminology. Right. So what actually is the Bitcoin address? Sid, what do you think?
The Bitcoin address is where you receive inputs and can send outputs from, and also store. So receive, send, and store.
Okay. So you can receive money to an address, you can store money on that address, and you can spend money from that address.
Right. Yep.
Okay. Yeah. No. That sums it up.
My basic understanding of the functions.
You
can use an address for to mimic like what you would do with a bank account.
Exactly. So let's step by it 1, 2, 3, right? So first we receive to an address. Now what does that mean, Sid?
That means I receive unused UTXOs that I can now spend or store. Okay. Send or store. So I've received them, now I can send or store them. That's my understanding.
Okay, and so you receive them in a Bitcoin transaction, right? So on the output side of that transaction is your address, right? And then you have received. Now, where comes to holding in? What does it actually mean to do holding?
In layman terms, it's to save, but it's just to hold your transactions for future optionality. For whatever reason.
Yes, you save your money for the future, and so that you can spend it on whatever you want in the future.
Right. So the power is in the unused transaction, kind of like a bomb. Like once you use a bomb, it no longer has the power of the threat of the bomb. So in the same regards, like you have these unused transactions until you send them somewhere else to be used or lose control of your keys.
Yeah. So you have to destroy the coin when you want to spend it, right?
Yes, essentially.
Sacrifice it. It's going to be gone. Right?
Correct.
That's interesting. What is that aspect to sacrifice something?
But is it really sacrificed, or is it kind of moved to a new state? Because like it's sacrificed on my end, but then it's created for somebody else, isn't it? Because it's I've sent it to someone, so I've destroyed mine, but then they
have a new one. So the unit is still there, or the units.
Very interesting. So the actual units of the coin, what are these units? What are they called?
Well, we call them Satoshis, or
Exactly.
you can call them whatever you want, but there's 100 million, it's divisible by 100 million. And so we can, if you go to that level, there's Satoshis.
Yeah,
and
exactly.
those are the bits that we send around. But you could send a whole coin too. But yeah, if I send my coin, I lose the ability to use it or spend it, but now someone else gets that ability.
Okay, but now that's interesting, right? So we have a coin, which and we have Satoshis. Satoshis are like the granular units of this coin or of this asset, and the coin is a chunk of Satoshis, basically, right? So same as with gold, we have atoms flying around, just individual units, and then we have a coin, which is literally a chunk of these atoms in one dense field, right?
Right.
And finally, this is why it's called Bitcoin, right? Because of this UTXO model, because of this unspent transaction output model that we've elaborated now for these last couple of minutes, right? That's why Bitcoin is called Bitcoin, precisely because of that aspect, that you destroy one granular or one chunk of granular units to send them somewhere else. And although you destroy the chunk, right, you spend the coin and it cannot be used afterwards again. The actual units flow on into another output, right, into a new coin, a new unspent coin. This is actually, so quite nice that we've discovered this here so intuitively. Now, one important thing that I would still like to really hone down on is what the address is, because we have many things floating around here, right? So the address can be a public key, right, where you need a signature. It can be multiple public keys, where you need multiple signatures, and maybe there are even more advanced things that we can put into this address. So how can we more generalize what this actually is? How would you, or what do you think? Like, in very generally speaking, not specifically, what is a Bitcoin address set?
It's a set of numbers, isn't it, that I can provide to somebody to receive inputs. So it's just a string of numbers. That's how I would view it. That were created by my wallet to set up whatever, in Herman's terms, an account. So, and I could have multiple wallets if I wanted multiple accounts.
Yeah, good point. The address is just information, right?
Right.
Bits and bytes, zeros and ones.
Right.
But it's so it's an accurate definition, but it might be a bit too broad, right? Because not any information is an address. So specifically, what type of information is a Bitcoin address?
Would it be private information?
Okay, private information is information that you don't share, right? So is a Bitcoin address something that you don't share with anyone?
Not your public address, right?
Yeah, right. The address is public. It's meant to be out there, right? So in this part, where is the private information? Which information should be kept private, John?
Your keys and your XPub, right? The primary, I guess, the primary public key.
Yeah. So of course your private keys ought to stay private, right? As well as to say generally information that links all of your addresses together, right?
Okay, right.
That is the extended public key. Why this is a bad thing and how exactly it works is, I think, a bit out of scope for today, but definitely very interesting to look at. But so yes, the information per se is not private information, right? But the private key behind this. But here, John, you found an interesting link between a private key and an address. Like in that context, again, how should I phrase this question nicely? In the context of Bitcoin, right, where we want to move units of currency around each other, like in this context, what exactly is the Bitcoin address? Herman.
that gives me the, I mean, I've got the rights to it, you know. I've got the sovereignty. I'm sovereign over my numbers, my figures, my energy, and I can decide what I'm gonna do with it. You know, that's, and I've got the backhand, not only the front end. And because it's asymmetric, so I can create a new public key and new addresses, and I'm the creator and the sovereign.
Okay, you bring up a couple of very interesting points, right? So first of all, you create the address, right? This is something that you create, of course, or your software creates. So this is something that you have control over, right? You decide which address you give to someone else so that he pays to that address, right? And it's your choice what exactly goes into that address. And you also mention that that you can define this address in a way that it gives you exclusive rights to control this money, right? And I think this is the key point of what the address is, right? It's a definition of who can spend these Bitcoin, right? That is the Bitcoin script. And that is what we use in many different ways or form. So Eric Kaysen, how like in the context of Bitcoin scripts, how do, for example, single public keys fit in?
How does a single public key fit within a script's framework?
Yeah, exactly. Or how can you use a public key inside the Bitcoin script?
Essentially, the script is stipulating how you can spend, and you can put that public key in to say, I'm going to explicitly spend to this public key from this public key. Let's say if you were using your XPub, you could use that to derive your next public address that you would want to have, those sort of things. So I guess it's almost like a command within the script.
Mm-hmm. Yeah, you're actually right on. So you can put in this Bitcoin script a command that says, so the script says, check the signature and see if it matches with this public key. This is basically what the script says: object and object sig and then the public key. So basically, this is saying that anyone who can provide a signature to this public key provides a valid witness to the script, and with a valid witness of the script, you can spend these Bitcoin. So yes, said. How can we then, for example, put multi-signatures into this context of Bitcoin scripts?
Multi-signatures allow you to interact with multiple parties. I think of it for security reasons. If I own a company and there's multiple stakeholders, and this way we can have security that one person's not going to release or spend the UTXOs. So I see multi-sig as an ability to secure your keys either as an individual entity, maybe use a 2 out of 3 or 3 out of 5, but then also to set up more complex transactions, whether it's just to hold it and prove no one, feel safe no one's going to spend it, but also to set up maybe more smart contract type interactions where if X happens, then Y gets released.
Yeah, no, really, really good points, right? So again, with multi-signatures, you can distribute the requirements that need to be met in order to provide a valid witness and to provide a valid transaction to spend this coin. So for example, in a company case, right, you have 3 people, each of them has a private key and a public key. And now you put into the Bitcoin script itself, check the signature from 2 out of these 3 public keys from Alice, Bob, and Charlie, right? So you put 3 public keys into the script, as well as the number 2 to check that 2 of the 3, there need to be 2 signatures out of these 3 public keys in order for this script to be valid, right? So this is the object multisig script. And again, this is a way to, in the Bitcoin programming language, Bitcoin scripts, to define this shared ownership, right? That multiple private keys need to acknowledge or need to be proven ownership of, so that this is a valid transaction. Seth, go ahead.
Yeah, so you said earlier that multi-sig is more expensive I think quantitatively because there's more data. So, 2x the data, maybe 2x the transaction fee. Is it qualitatively more expensive too, where it's a little bit more than just double the price because you have double the data? Is there a complexity fee like kind of added, or is it just straight more data, more fee?
Very good question. And there are multiple aspects to it. Let's talk about that is the one that's probably most relevant for you, and that is the mining fee, right? So how does the size of the multi-signature affect the transaction fee, the mining fee? And here it's pretty linear. The more public keys and the more signatures you put in a script or a witness, the more you pay in fee linearly. Because the mining fee is calculated in Satoshis per virtual byte. So for every virtual byte that you add, you pay X Satoshis more. So this is a pretty linear approach. However, there's one interesting nuance in the cost of verifying a multi-signature, right? Because how this currently works in the Bitcoin space or in the Bitcoin script is that we have the script that has 3 public keys, public key A, B, and C, right? And the number 2, meaning that you need 2 signatures out of these 3 public keys. Now the question is, how do you actually go about checking whether 2 out of 3 signatures were met? What are some of the logical conditions that you would need to use to verify that 2 out of 3 is actually met? Eric Kaysen, what do you think?
Essentially, to validate those 2 of 3 signatures, you would need to essentially, well, it depends on the transaction type as well, but like in a partially signed Bitcoin transaction, you would need for the quorum to have circulated and for at least 2 of the 3 to have provided their signatures vis-a-vis revealing their private key and displaying that they have signed off on the transaction.
Yes. And so let's assume that these people who make this transaction actually provide 2 signatures, right? So now your full node is verifying this whole thing, and it sees a Bitcoin script that says object multisig 2, public key A, public key B, public key C, right? And now you have a transaction that spends this coin, and this transaction has 2 signatures, right? Now, how is that, like, how would you go into verifying efficiently whether 2 out of 3 was actually met? Like, this is, I'm going more for like a logical if and else or conditions. Maybe the question is phrased a bit weirdly, but Eric?
I suppose the most efficient way would be to check for each transaction slot, essentially A, B, or C. And if A and B are together, then it should pass. If A and B does not, then B and C. And if B and C adds together and passes, then it should be valid. And so I think it would go through the operation to check for if A and B is true, then yes. If A and B is not true, then is B and C true. If not, then does not pass. So
spot on, Eric. That's exactly how it functions in the Bitcoin system, right? So you have 3 public keys and the threshold is 2. So what you do is you create all possible pairings of 2 public keys out of these 3. So you take A and B, A plus C, and B plus C, right? So if you want to verify for 2 or 3 signatures, you verify if these signatures are either from A and B, or from B and C, or from A and C, right? So these 3 conditions have to be met. Now notice already you have to do quite a lot of combinations here, only in the very small case of 2 out of 3. Now, how does this scale? How does this change when we have, for example, a 2 out of 5, right? Herman, can you come up with some of the combinations that you have to check out of 2 out of 5 from A, B, C, D?
Not really. For me, it's like when the temperature is over 25 degrees, the Renner-Job protocol. If it's over 25 degrees, the climate's, the air condition is coming on. This would be my answer. So the probability A, B, C, D, E, F. I'm lost here. Sorry.
Okay, no, that's very good that you actually also say this, right? And that always gives us the feedback to realize that we're off in the weeds here, and that it's getting unclear. But yes, how can I okay, so
I think the point there is like that it's just exponentially complex, right? Beyond a certain point.
Yeah, exactly. It gets more and more complex with more and more M and more N, like more and more participants and threshold that you have. And this is a serious problem because, for example, one entrepreneurial use case for this is that is happening right now on Bitcoin with multi-signatures is the liquid sidechain. And don't want to get too much into the technicals, but the liquid sidechain anchors its transaction or its blocks its peg-ins and outs with a 11 out of 15 multi-signature. So 15 public keys and 11 signatures are required. Now, this is incredibly complex to actually verify. And the computational cost that a full node has increases a lot. So this now brings it all back to Sed's actual question, was that how much more does it cost to add more people to this multisig? Well, the cost for your transaction fees is pretty much linear, but the verification cost is exponential, right? Because this is actually a really complex thing. So complex that it blows Herman's brain to over 25 degrees, right? But this is not just complex for us to reason about. It's actually really complex for computers to calculate as well. Okay. But I think we have somewhat described decently well now the like how Bitcoin works, right, on a transaction level, that there are inputs, right, which provide a valid spending condition, a valid witness that proves that the script, which is in the address, has been verified. So, for example, the script is a public key, meaning anyone who has who proves the knowledge of a private key with a signature can spend this coin. But that's exclusive, right? So you cannot spend the coin if you do not have the private key, right? So we exclude here, as Herman said, this is like mine, this is our sovereign property, right? Because I define the address, I can say that, well, only a secret that I know has to be proven before this coin can be spent, right? And we come to the conclusion that there's the Bitcoin script, right? And here in Bitcoin script, we can define programmatically the property rights condition of this coin. And this can be something as simple as a single public key, where only one signature is required. This can be a bit more complex, like a multi-signature, where there are multiple public keys, and a sub-threshold from these have to be provided. And here we realize some of the downsides. They're pretty large and very complex to verify. There are, briefly, I think Seth mentioned it, that there are some other cool use cases that we can do with the Bitcoin script. And you mentioned the Lightning Network briefly, Seth. So maybe you can explain a bit how the Lightning Network actually uses Bitcoin script. What is the Bitcoin script of a Lightning Network transaction?
I'm not sure what the script is, but the way I understand the Lightning Network is it's kind of like an intranet or intranets you can build on top of Bitcoin. So I could have my own channel, I could have a channel with you, and we can do a lot more things between us on that channel that we can't necessarily, or because Bitcoin is more stoic and foundational, so we don't mess with that network, but we can do more experimental things between us on the Lightning Network. And it acts more like a TCP/IP protocol that we could just build out nodes between as many people as we want. It's kind of how I see Lightning in a conceptual form.
Yeah, no, really, we're spot on. So the Lightning Network is a network, meaning multiple peers interconnecting, and they specifically connect via what's called payment channels, right? And then you can do stuff inside this payment channel, and not just inside one, but you can route this throughout the entire second layer network. And the cool thing is, we can modify the rules inside these payments channels a bit more recklessly than we do on chain, or than we do on the first layer, right? Because this is a new network with different consensus rules, basically, in the nuances. So we can experiment and be a bit more reckless. And if that fails, at least the big Bitcoin project itself doesn't fail, right? Yeah. So these are nice things.
I want to go back to the network though. So if I have an address and I have a public address, and let's say I have you know, 1 Bitcoin on there, and kind of like proof of reserves, I want to prove to you that I own this account and that I can control it. I don't want to give you the private key. So how do I do that? Kind of like, how do I prove my ownership without giving you information that you now have ownership?
Now that's a really good question, and there's an easy answer to it, but it's a very difficult problem that actually cannot be answered. Let me try to explain that now. So the easy answer is, whoever has the knowledge of a private and a verifier can verify that the signature is valid to the public key without having any knowledge about the private key, right? So this is the beauty of private public key cryptography. Now, in the Bitcoin sense, there's one other layer that you actually, in order to prove that you can spend this, you need to provide the actual Bitcoin script, right? So the actual programming language operational codes that are being executed. Like, again, who can spend these coins, the actual definition of the property rights of this Bitcoin. And then you need to provide a witness that verifies all parts of the script. Okay, so in the easy case, if the script is only one single public key, right, then you need to provide the script, so object sig public key. But you also need to provide that signature with your single private key, provide one single signature. And in this case, the script is fulfilled because the script asked for nothing else other than the signature of this public key, right? Nothing else. However, if your script is more complex, like let's say a multi-signature, then all of a sudden, one signature is no longer enough to prove it, right? So you need to prove, for example, 2 out of 3 signatures in order to produce a valid script, a valid witness to a script. So in order to prove that you can spend a coin, you need more than just one signature in the case. Sometimes you need many. So you basically have to validate the entire script so that you can prove that you can spend it.
I'm kind of lost on this. How do I do that like with another party? So I feel like what you're saying is I'm interacting with Bitcoin Core and I'm running or showing the script, and that I have some sort of key to it. That's not my private key. And that's kind of where I'm just not fully grasping. Like, how do I show you that do I send you some sort of cryptographic output? Do I get some sort of output from the system that says I ran the script successfully, and that I can then show it to you? And then how do you know that it's legit?
Yeah, that's a very good point. So the way that this is usually done is by because it's difficult. Also in the nuances of cryptography. Sometimes there's like weird edge cases where you can where you could be able to provide a valid signature of this private key, but you cannot provide a valid script because there is some quirk in the script. So the verifier really must verify the entire Bitcoin script. And the way to do this, and specifically in Bitcoin Core, is that the prover generates a transaction, so a Bitcoin transaction with inputs and outputs, and an actual Bitcoin transaction that spends these inputs that you want to prove that you have ownership of. And it also has an address and so on, but this transaction is invalid, or is like in the sense that the transaction itself cannot go into a block. although the witness is valid. So basically you have a signature over the transaction, or you have a valid signature over a transaction that cannot be confirmed in the blockchain. Maybe that's the way to put it. So this way, the verifier can actually see, hey, this is a completely valid witness to the script. This this person was able to prove to build this valid input and completely, and this is completely solid. It's just that this specific transaction that you have is not capable of being confirmed, which is what you want. Because again, you don't want to spend this coin. You just want to prove that you have ownership. So you don't sign a valid transaction because that would get confirmed, right? So you sign a broken, invalid transaction that cannot get confirmed, but that the other party can actually verify that it's accurate. Does this ring a bell?
Doesn't ring a bell, but I mean, it makes sense to me. I'm trying to think through two things. Like one, when a reserve or an exchange wants to prove they have the reserves. So I'm wondering how and I think there's one exchange in the UK that claims to do that. And then, if I were to down the road want to use my Satoshis as collateral, how do I prove it to somebody like a bank?
Yeah, very good question, right? So the easy answer is build a valid witness to the script. Bitcoin Core has this nicely integrated, Electrum Wallet 2, you can sign even with multi-signatures and so on, random messages, this is doable. But it only answers half of the question, because what you were saying is proof of reserve, right? And that is different from proof of capability to spend, right? Because just because you have the private, so you can prove me that you have the private keys and so on, right? With and that you are able to spend the coin. But what you do not prove is that there will be negative precautions or negative consequences when you spend the coin, right? So specifically in the case of proving reserves, you cannot prove that some other third party has a claim of debt on these coins, right? Because maybe you went to the bank and said like, hey, give me your credit for 50 Bitcoin, right? And now you have 50 Bitcoin on your keys, and you can prove ownership of the keys, and you can prove that you can spend them, right? However, this proof does not include a proof that you do not have this on, that someone else has a claim to these Bitcoin, right? So you might be able to spend it, right? You might even legally be allowed to it, but there's another person who has a claim, a debt guaranteed by these coins. And this is where the proof of reserves comes in, right? Because one thing is that the exchange proves that he actually has the Bitcoin, right? Physically, that these Bitcoin exist. That's one proof, very important. But the other thing is, what is your debt? How much do you owe other people, right? Because if you owe all of these Bitcoin to someone else, well, then the proof of reserve was useless, right? And here is, again, where Bitcoin does not solve this very, very complex problem. Bitcoin solves the problem of proving that you are capable of spending, but it does not prove that no one else has a claim on these coins but you. And this is where financial audits come in, right? There are experts and special companies who focus on auditing and reviewing the balance sheet and the treasury and the holdings of a company. Many auditing firms out there. And this is what they do. And this is why they get paid a damn good money for, because it's really, really, really complex to do. And unfortunately, Bitcoin does not really solve it. It solves the provability to control, but not a proof of a negative, which is that nobody else owns these coins. Does this somewhat answer your question?
Yeah, definitely.
Okay, nice. So I think by now we've laid a decently good groundwork for let's say the current status quo, right, of how Bitcoin works with the transactions and so on, the scripts. And we've already talked about some use cases, right? So for example, the company spreading his funds and so on, as well as the Lightning Network, right? But now Now let's see how Taproot actually comes in, and what Taproot actually solves. So there are two important base technologies of Taproot. One is called Schnorr signatures, and the other is what's called MAST, Merkleized Abstract Syntax Trees. Bit of a complex name, but let's go and explore each of these two categories. So Eric Kaysen, what are Schnorr signatures?
So Schnorr signatures are essentially a new scheme that allows for signatures to be aggregated in a simpler method. So MFN, for example, you can just add signatures together directly to tell if they're valid, as opposed to needing to do other operations to do that.
Yes, that's already one of the very advanced use cases possible with Schnorr signatures, the key aggregation and signature aggregation. It's important, very important actually. Let's talk about that in a bit later. First, so fundamentally it's a signature scheme. Eric, you said that it's a new scheme, but can you, or is it actually that new? Is Schnorr signature something novel?
You know, my knowledge of it isn't as detailed, so I couldn't comment too much on it. I should be closer to reading up on this, but for now, my understanding of it is relatively rudimentary.
No, that's all right. And always good just to state that, hey, never thought about it, never read it, never looked into it. I don't know. Again, I don't know a bunch of shit either. This is why we're here, right? To ask these questions and to discover it. So good that you bring it up. But Zed, do you maybe know a bit more about?
Yeah, I think it goes back to maybe the 80s or 90s, and I think it was commercialized or under patent, and that's why Satoshi couldn't use it then right away. But I think it's since the patents either run out or it's more open source now, and more. I think it's been more vetted. I think it's had more time to be vetted since the earlier days.
Yeah, so says right here, this is really one of the earliest signature or cryptographic signature functions or algorithms that we know of. Some Professor Schnorr out of Munich invented it, some in 80s, 83 or 82 or something. And it's a very simple mathematical formula. I don't know it off the top of my head, but it's like very, very small, very simple. And because it is that simple, wait, one step back. So it's a very simple function, and it does all the things that a signature ought to do. However, as Seth said, that Professor Schnorr put a patent on this. So he said, anyone using this math formula is going to be killed by the government, right? So better don't use my math formula because these are my numbers. Yeah, very stupid. But anyhow, of course, because of this huge threat of violence, many people were afraid of using this technology, and it was not widely adopted. Then there was an effort, I believe in the late 90s or so, to get or to tweak this mathematical formula a bit to make it look different but behave similar. So to get some of the nice advantages of this mathematical formula, but it looks sufficiently enough different so that we don't break the patent rules, right? So that was the awkward thing. So we have this beautiful technology, this beautiful math formula. Unfortunately, we get killed for thinking about it. But let's tweak it a bit. Let's make it look a bit different, but still keep the essence of it, that it is a signature, that you can provide signatures and you verify and all of this, but just not to break the patent. And this is what is known as the elliptical curve digital signature algorithm, ECDSA. Right? So this is like a kind of a troll move to break the patent of Schnorr by tweaking the formula a bit. And it still does all the signature things. However, it is not as beautiful. It is not as simple and not as like pure, basically, because you had to add a bunch of other stuff. And that other stuff makes the math a bit weirder. I don't want to go into the depths of it, but some of the cool use cases based on the simplicity of the Schnorr algorithm are no longer possible or no longer as easily possible with ECDSA. Right? So this is the main gist here. Now, also one more fun fact said is that actually by the time of 2008, where Satoshi wrote the Bitcoin code, the patent was over. It was already expired in 2007. So Satoshi could have used already, without government force, this code or this cryptography. However, of course, because if you force many people, or if you don't allow people to think about something, they won't. So nobody implemented nice software with Schnorr signatures. Contrarily, specifically the OpenSSL library, which is like a cryptographic library, had a really good implementation of ECDSA, right? Because this was just the cryptographic algorithm to use for all these years. And although now the Schnorr patent was expired, still nobody wrote well, efficient, and secure and reviewed libraries on top of it. And this is why Bitcoin is stuck with ECDSA as of now. So let's see then some of these cool aspects of and benefits that Schnorr signatures enable. Eric, you mentioned one of them, and that was key aggregation. Can you maybe speak a bit more about what the key aggregation might actually be?
Yeah, essentially, if we're doing an end signature, instead of doing that operation that we were speaking of before, going through the operation of, check A plus B, check A plus C, check. And so instead of going through the entire list of trying to check all of the different variables that there could be for a valid transaction, on the back end, instead, you can actually just add the signatures together directly to see if they pass the threshold check in order to be able to create a signature. And that allows for essentially the transactions to be aggregated through a different methodology that allows for saving on essentially both data and actual Bitcoin transaction fees.
Yeah, that's a very good summary of the whole thing. Let's dig a bit deeper about one thing, and that is the public key aggregation part. Not sure exactly how to phrase this because we're getting into the gist of it now, but John, do you think that, or what do you think is required to form a aggregated public key? What information is necessary?
You're muted, John.
Sorry about that. I think you would need the combination of all of the participants' public keys. Is that how it works?
Yeah, pretty much. You need, of course, if you want to aggregate public keys, you need to have know all of the individual public keys, right? Do you think that there's any other important information required?
I imagine you need to know what the purpose of the aggregation is. Maybe like deciding what they're going to do.
Yeah, that's a good point. Yeah, so you need to know how many you want to aggregate, right? Do you want to aggregate just 3 public keys or 15, right?
Okay.
So that needs to be known, and that kind of leads us to an interesting conclusion or to an interesting realization that like all the information that you need basically is the public keys. And then anyone who has multiple public keys can himself aggregate them, right? So you can choose for yourself how many of these public keys you want to aggregate. This is not something that has to be communicated in a round, like multi-round process. In the sense that, for example, if we all in here in this chat group now want to aggregate public keys, we don't have to talk to each other like 10 times to figure it out. But all that we need to do is everyone to share his public key, and then anyone who has all the public keys can himself generate that aggregated public key of all of us together. So that's quite nice. You don't need any other information other than the public key. But now comes the interesting part. How do you then produce a signature for this aggregated public key? What do you think, Eric?
Oh, just got back. Sorry, I missed the question. I was off to go get coffee.
Oh yeah, that's good to stack up on coffee.
Yeah, I need that this morning to get my brain going. So my apologies.
Okay.
What was the question?
The question was what is needed to produce a valid signature for an aggregated public key?
Public key. Whatever. So is this just for a normal transaction?
Now we're not even just talking about a Bitcoin transaction. Right now we're still at the level of let's say pure cryptography, not even applied in Bitcoin. Just for one aggregated, so we have multiple public keys. We aggregate them into one single public key, and now we want to produce a valid signature for this public key. What do we need to do?
We would need a signature from, I guess, from the XPub that kind of creates the aggregation of those public keys. We would need to get the private key signature to validate for that aggregation of public addresses, I think.
Yeah, that's interesting. So because we have individual private keys and individual public keys, although they're aggregated, right, there is not really an aggregated, or we don't really want to aggregate the private keys, right? Because we want each individual to still retain his individual private key and not to share it with everyone, right? So we don't aggregate the private keys. Rather, every individual private key produces a signature over the same message, right? And now with all of these, or with every individual signing the same message, specifically, and that's important, the signing phase is interactive. So when we as a group sign one message, we actually have to talk to each other, I believe, 3 rounds, like where we say 3 different things and everyone has to be caught up to speed. So this is contrary to the key aggregation. The public key aggregation does not need any interaction. We just need to get all the public keys, and then you can calculate the aggregated public key all by yourself. But for the aggregated signature, we actually do have to communicate multiple rounds, right? So that is something to keep in mind. Specifically for use cases, we don't have to talk to clients for aggregating the public keys. But if you want to sign a transaction collaboratively, you actually do need to communicate multiple rounds with each other, right?
So quick question there. So signing the, in order to sign the output, you need a participation with everyone's signatures from everyone's private keys, and that would be used for what use case, or I guess what is the use case for that? Like that would be if this group of people want to transmit information out of it, or receive information into this aggregation of, or
yeah, let's walk through a use case on how this might function. I'm not too sure on the details myself, so but the gist of it I think is correct. So let's take an example of you having an air-gapped hardware wallet. Let's say your cold card, right? So that you really realize the rounds of communication. Now, the first thing that you need to do is to commit to a nonce. So a nonce is a random number, and a commitment to a nonce is a hash of a random number. And this has to be generated by the hardware wallet. And now you take that nonce commitment, the hash of a random number, you put it onto an SD card, right? And you give that SD card to all the cosigners. Simultaneously, all the cosigners also create their nonce, their random number, and commit to their nonce by creating a hash over the nonce. Right? So at this end of the first round of communication, you gave your nonce commitment and you received all the nonce commitments from everyone else. Right? That's the first round of communication. So you, you take in all of these 8 inputs. So you take all the SD cards and put the nonce commitment basically into your cold card. That's the first round of communication. The second round of communication is where you actually reveal the nonce. So the nonce, this random number that you used, this has to be revealed as well. I think it has to. Yes. The R value. The R value, not the nonce, the R value. Forget about the crypto magic, not important. But there's the second information, the R value, that you now generate on your cold card, on your hardware wallet, and you put it on the SD card and you give it to every one of the cosigners. Right? And simultaneously, they generate this R value, put it on the SD card, and give it to you. So that's the second round of communication. We still don't have the signature. Now your cold card takes the nonce and the nonce of the others together with this R value from everyone else to now produce a valid signature or a partial signature. This partial signature is still only valid to your individual private key, right? And not yet aggregated. So you only create that partial signature. And you put that on the SD card, right? And finally give it to everyone else. And simultaneously, everyone else gives their partial signature. And now, finally, whoever has all of the partial signatures, let's say this is a 10 out of 10 multi-signature, right? Whoever has 10 partial signatures, because all of these partial signatures use the same nonce and something like this, they can be aggregated. And now we take these 10 partial signatures, we aggregate them to one final signature, and this final aggregated signature is valid to the aggregated public key. But here maybe this was an intuition of how there are multiple rounds, specifically 3, required to do a secure multi-signature. Right? And you might see how this already hampers the use cases, right? Because it has this online or this communication requirement, right? I mean, Eric, what do you think? Is it a reasonable UX that you have, like that you have to move SD cards 3 times before you make a transaction and sign it? Or maybe he's still out for coffee. Said, maybe. What do you think? Is it a good UX?
I think Zed is out. Is out too. He's taking a break.
We're actually joined by Ian. Can you speak? Hello.
Yeah. Hey guys. Sorry, I crawled in a little bit late. I suppose it depends on the type of transaction, right? Or it could, in terms of just that suitability. You're asking about the UX itself of that transfer mechanism of SD card through these different waves of communication, or?
Well, yeah, I mean, you say it depends. And that's, of course, always the right answer. Well, what does it depend on, right? When is this type of UX okay and when is it not?
Yeah, I guess, transactions where, kind of low time preference. So you could, wait for it to complete and you're not in a massive rush. I suppose transaction value could also play a role. Those would maybe be the first couple of things that come to mind.
Yeah, right. Time preference. So how quickly do you want to have this signature done? And here multi-signatures are more time consuming, right? Specifically the coordination, but also the security, right? You arguably get more security from it.
Right.
So if you rely on high security, then that's a good idea. Sed, what do you think?
I thought it sounded very complex and cumbersome to go through the 3 SD cards to do a transaction. I don't know how things progress or if it gets easier, or maybe that cumbersome is needed in certain multi-sig transactions, but it seemed complex and cumbersome.
Hmm. Yeah, no, I totally agree, right? Here specifically because, in our case with 10 people, 10 people have to get together 3 times to share and exchange information. It's a coordination cost, right? Absolutely. However, just let's keep in mind, I only made that example with the SD cards to show that there are really 3 separate communication rounds, right? And you can do this with SD card and completely air gapped or QR code, right? If you really want to go crazy secure. However, you can just connect a USB stick, right? Or like a USB cable, and it's done within a millisecond. Um, so, um, but here that's like one of the things, right? Because right now, or one of the changes that we will have with Taproot compared to today. Today, in a multi-sig environment, you can go to your cold storage, right, and just sign that partial Bitcoin transaction one time, leave the cold storage and never return, and the Bitcoin are sent, right, and you can continue. But that is not possible with Taproot or with with Music and Schnorr signature specifically, right? Here you have to have multiple rounds of interactivity, so that can actually be a downward pressure on the use case for Taproot in let's say cold storage requirements, specifically when Music is involved. But what about the online, or what about when the wallet is online and can actually send and receive this stuff swiftly over the internet? Um, what do you think? Or like, can we assume that for some use cases this is all right to um, sorry, like to be online and send this information quick? Or maybe to, or sorry, go ahead.
Well, I guess my initial reaction is that yes, that it would increase convenience, but it would also perhaps open up some vulnerabilities for security.
Yeah, right. That's a new concern always when we touch new cryptography. Is this actually secure, specifically in these settings? And not just is the crypto secure, but also the implementation, right? So this is one of the big concerns that we have here. Also as entrepreneurs using the Taproot, is this actually secure, or will my entire business break when Taproot breaks too? And that's an important consideration. Of course, neither of us are cryptographers, I think. So we kind of have to trust on someone else to say or to see if this is right or wrong. But hopefully, it's well reviewed.
So what you're saying is Taproot takes that process and enables a more a more efficient use of that process online, like through the internet. Is that what you're saying?
So I think it's interesting here because so on one side, Schnorr signature increases complexity, and on the other side, it reduces it. And that's an interesting trade-off that I think tells you a lot about the ethos of Bitcoin, kind of the mindset of Bitcoiners. So, how is this affected currently? Currently, it is very easy to provide a signature for the multi-sig in Bitcoin script. So in current multi-sig, creating the signature is easy. Because you just have to provide 2 signatures out of any of the mentioned public, right? So this works great for the hardware wallet case. However, the verification cost is much more difficult, right? You need to crunch through all these public keys and verify like 7 signatures and see if they are in all the correlation correct. So it gets very difficult for the verifier, right? So we have ease of use for the sender, but high cost for the verifier. now this is maybe something that is not optimal, or no, now let's say different, that Taproot specifically and deliberately flips this upside down. So now it becomes more difficult for the sender. For example, there are now 3 rounds of communication, right? And you have to do this interactively now. It's more difficult for the sender to do this. However, for the verifier, it is much simpler, because he only receives one aggregated public key and one aggregated signature. And he does not care if this comes from one single private public key, or if this comes from 100 private public keys, right, in a huge 170 out of 100 multi-signature. The verifier doesn't care. It's just one public key, and it's only valid if everyone signed it. So that's it. I don't care how complex it is, right? And I think this is a general kind of the general intuition of Bitcoin in general, but Taproot specifically, to increase the cost for the sender, and to decrease the cost for the verifier. Now, of course, not maliciously, but in a question of trade-offs, what do we favor? The verifying cost is very often favored in the Bitcoin ecosystem. Now the question is this actually a good favoring, right? Ian, what do you think? Is it good that we favor verification cost over spending cost?
Yeah, I would have to say yes. I mean, that's, you know, the fundamental building block of keeping the network, you know, secure and with integrity.
Mm-hmm. Yeah, right. That's what makes Bitcoin Bitcoin, is that you verify for yourself if the transactions are upheld. So if that is lost, we have a big issue. Seth, do you maybe know of any historical examples where the Bitcoin ecosystem favored verification over spending?
I think Seth had to duck out for a minute.
Okay, well then, John, I forward the question to you. Have you heard in some history lessons of Bitcoin where verification was preferred?
Yeah, it brings to mind the Bitcoin Cash debate, right? Like the fork, where there was this massive debate between are we going to favor transactions and the sender's convenience, or the sender's cost of interacting with the network, or are we going to favor the verification and keeping the validity, keeping the integrity of the network prime? So
yeah, exactly. That's really it. And it's not an easy conclusion to reach, right? That verifying is more important than spending. And funnily, every Keynesian economist would vehemently disagree with you, right? Because spending is what makes the economy thrive, right? That's what brings in the velocity of money. That's where people get paid and all, right? So when you spend your money. So doesn't that, like, Bitcoin's tendency to favor the verification over spending, doesn't that hamper economic activity? What do you think, Eric?
Well, no, I think what we've seen with the proof between the Bitcoin Cash hard fork and where Bitcoin's at today, it turns out that that's not actually true, and that Keynesians were wrong. Shocking.
Who would have known?
I'd say just to add on top of that, what it looks like is it puts the impetus on individuals who want to use Bitcoin, use the network for more things, to develop new solutions and in other areas. So I'm trying to formulate what I'm seeing in my mind right now, where you have this very secure transaction, very secure verification process, but that's not able to be changed. And so all of the energy and cost is put on other people who want to provide more solutions, more elegant solutions, or more cheaper transactions in other layers. Does that make sense?
Yeah. So using the block space more efficient is always desirable, and specifically when we can use it on chain in a way that it also leverages second layers. And I think this is another aspect where Taproot is so promising. That not just does it, for example, decrease the verification cost tremendously just by aggregating signatures, it also improves a lot of capabilities of, for example, the Lightning Network. Now, why is that? So multi-signatures are important. We clearly figured that out, right? But the question is if it's enough. And so let's maybe come up with some other cool scripting capabilities that define who can spend this coin that are not necessarily public keys and signatures, right? So neither single or multiple. Let's leave this out of the view and let's see at what other capabilities a Bitcoin script provides us with. So Eric, can you come up with any of the other scripting technologies that can be used in Bitcoin?
One off the top of my head, it would be end time lock.
That's one of the good ones. Yes. What does end time lock okay. Okay. Please explain what end lock time actually does.
Yeah, essentially it's a script that says, these coins cannot be spent until such and such block has happened. And so you can project outward to say, if we don't want this to be spent for, say, a month, we can estimate what block we could essentially link this transaction to so that it cannot be spent until that block has passed.
Mm-hmm. That's a very good explanation, but it's not for end lock time. It's actually for check sequence verify. Op check sequence verify, CSV, is the opcode in Bitcoin script that does exactly what Eric just explained. So if this opcode is in the script with, let's say, block 700,000, then it does not matter if you have a valid signature or not. It does not matter if all of the other parts of the script you can provide is valid. If it's not yet block 700,000, you cannot spend the coins, right? So this is a way to limit or to set a limit when the coin can be spent. So you cannot spend the coin before this time period. You don't have to spend it at the time period either, right? You can wait and spend the coin at block 800,000 if you want to, but you cannot spend it at block 600,000. So yes, but to hark back, what end lock time is, it's a very similar concept. It has also something to do with time locks, but it is the main difference is it's not a Bitcoin script opcode. So there is no end lock time opcode in the script, meaning end lock time does not is not regarding who can spend the coin. The script does who can spend the coin, and object sequence verify does. And lock time is about the transaction, meaning when is the individual transaction itself valid or not valid. Or said differently, you can make a transaction that spends any coin to any address, and you can set in the end lock time field when the transaction can be mined. So for example, already today, you can spend a coin, or you can make a transaction spending a coin in a valid transaction. However, you set the end lock time field to block 700,000. And then this means that this individual transaction, whichever coins it spends, can be more than one coin, right? And to whatever addresses it pays, can be more than one address. This entire transaction can only be in block 700,000 or later. So there's a subtle difference between object sequence verify and nlock time. Ian, does that make sense to Grok, or did I explain it confusingly?
I think so. I think so. I think I'm tracking. I don't know a better way to to like re-synthesize and attempt to check my understanding, but I think I'm there.
Yes, what's up?
What's that? Oh, nothing.
Oh, I thought you wanted to say something.
I'm just
Okay.
so that I guess try to resynthesize from my own understanding the I'm kind of mixing up the names of these two different two different concepts that we're talking about.
There's object sequence verify, and there's nlock
sequence
time.
verify and nlock time. So nlock time is having to do with transactions themselves. Object sequence verify can have to do just with coins or UTXOs that you want to lock up for specific for after specific block sequences.
Yeah, I think that's a great summary. So object sequence verify is a spending condition for one individual coin, meaning this coin can only be spent by whatever transaction after this block, while in sequence has nothing to do with coins. It's about the transaction, meaning this transaction that spends all of these coins to all of these addresses, this transaction is only valid after that certain block time, right? So yes, that's and now why is this important, right? Because Taproot does not change anything of the transaction structure itself, or like it does not change the nlock time field is what I mean with that. So Taproot does not change or is not affected by nlock time. However, check sequence verify is in the script of the Bitcoin, like of the coin, and Taproot does change the script. Right. So, for example, using OpCTV or object sequence verify is one of the potential use cases or one of the potential tools that we have in the Taproot use cases. Another one of these would be, for example, hashed time-locked contracts, which is so it enables you to, so you commit to, so there's a secret basically, let's call it that way. It's not necessarily a private key, but it's a secret. And you commit to the secret by hashing the specific secret. And later by revealing the secret, or the transaction can only be valid when the secret is revealed in this witness. So in order for the witness to be valid, the secret has to be revealed that was committed to in the script. And this again is one important aspect in the Bitcoin script toolbox that we can use specifically with Bitcoin script today. However, there are some certain drawbacks, and they're actually a bit similar to multi-signature drawbacks in the current case. So let me try to summarize that and then ask the question. So a hash time lock contract has a commitment to a secret on-chain, and then a revelation of the secret on-chain in a hash and a pre-image. Now, where might be here some potential issues with using this in the Bitcoin space? So we talked about some of that before. What do you think, Ian? What are some of the current issues with hash time lock contracts?
Just in relation to the speed at which a transaction can get executed, or?
Okay, so let's see. Is the speed an issue here? I mean, the speed to calculate a hash in the pre-image is trivial. So I don't think that speed is like a constraining factor here.
It's the primary issue, the cost. Again, bring it back to the cost of the transaction. If you want it to be, if we're dealing with things pre-Taproot, then that is going to be a very complex transaction, and thus create more data, more data to be exchanged, and just take up more space in the block to be mined.
Yeah, exactly. Right. So again, you put the hash on chain and you put the pre-image on chain. Right. That's again a lot of data that is added to the script and the witness, meaning the transaction is larger, and again you pay more fee. So this is one of the constraints. You're absolutely right. How about maybe privacy? Could you come up with some privacy constraints in the current HTLC model, Eric?
Yeah, and the current model, because of the way that there's several touching places where the transactions are on chain, it's revealing people's privacy, as opposed to if we have one single signature that goes on chain, that's going to do a better job in helping protect people's privacy.
Yeah, exactly, right. Every information that you put on chain is there for everyone to review and verify. And specifically when we put the information of a hash and a pre-image on there, then of course it's clear that there's a hash and a pre-image on chain. And this means that this transaction used a more advanced scripting capability. For example, it becomes clear that this is a Lightning Network channel opening transaction, for example, or channel closing transaction rather. So when we reveal this information that we use these advanced scripts, we lose some privacy, right? And I think that's one of the that's one of the great use cases of Taproot, and one of the great improvements, because we can get the same functionality to commit to a secret, to reveal the secret, and then something happens. We can get the same thing, but not with hashes and pre-images, but with private and public keys and signatures, in a way that is basically called discrete log. With something that is called adapter signatures. I don't want to go too much into the details here, but to sum it up, so there is a secret. The secret is just a random number, basically. And we have a private key alongside with that. Now we generate a public key, and from this private key. And now we tweak the public key by the secret. And mathematically speaking, it's just a plus. So we take the mathematical number of the public key and the mathematical number of the secret, and we add them together. 1 + 1 is 2, right? And now we have a tweaked public key. And this tweaked public key is the commitment to the secret, to that specific random number that we added. And now there's a cool way that we can produce a signature with this private key, but we add again that secret to the private key in the signature calculation process. And what we now reveal, or what we now have, is a tweaked signature. And the signature actually, in some cases, or it can reveal the information of the secret to a party who knows what to look out for, basically. Let me try to explain this a bit more simple. So the thing is, we want to commit to a secret and then reveal the secret later, but we want to do so without telling everyone else that we're doing it. So instead of putting it in a hash and in a pre-image on chain, what we do is we tweak a public key with the secret, and we put this tweaked public key on chain. Now, this looks like any other public key, and no outside observer knows that this is actually tweaked with a secret. And now we have committed to the secret. We can actually tell someone else, hey, this is the secret here, like look out for it. At a later point in time, someone else, or when we spend the secret, when we spend this coin, the signature that we produce actually reveals the secret to whoever knows to look out for it. And this gives us the same functionality as a hash time lock contract without telling the entire world that we're doing a hash time lock contract. So a question for you, Herman. Why is it an interesting aspect to not tell everyone what type of script you use, specifically if you're using this hash time lock contract?
So the reason why I wouldn't reveal the scripts I'm using, I think because it can be followed back to my public key and my identity, maybe gives me the privacy.
I would say so, right? Because if you're the only one who uses a very weird script, right, a very weird definition of your property rights in Bitcoin, and everyone sees that everyone sees coins moving with this pattern, then they might find out that this is actually you, right? Because you always use this weird script. Or said differently, it becomes obvious if you use the Lightning Network, right? Because the scripts that you use on chain are different than if you would not be using the Lightning Network.
Thank you.
Yeah. So we want to, or this is again where specifically Schnorr signatures in its simplicity and its beauty comes in to make us be able to use the same functionality that Bitcoin scripts provides without actually using these scripts. And that gives us more privacy. And now maybe let's sum up, or this leads us to one more important thing that Taproot entangles. So we spoke a lot about the signature part. And so Taproot moves from ECD's asignatures to Schnorr signatures. And that's a huge important part of it. However, there's this other thing that I mentioned, which is Merkleized abstract syntax trees. And this is, again, in the same light to not tell everyone what scripts you use. Specifically, in a more advanced use case where we have multiple spending conditions that are independent from each other. So let's say I have a spending condition with, at any time, this public key can spend a coin, or a 2 out of 3 signature can spend this coin, or after 2 years, a 1 out of 3 signature can spend this coin. So I string together in my property rights definition of who can spend the coin, this vast complex array of different conditions of who can spend the coin, when and where. But maybe does someone already see a problem in the naive way that Bitcoin scripts handles these complex spending conditions? Seth, do you maybe see some of the bottlenecks of how Bitcoin currently works with these complex things?
I don't really face a lot of the bottlenecks myself. So it's just really out of theory. I just hold my Satoshis. So I really don't have any personal experience with bottlenecks. I'm not doing any commerce. I'm not really interacting with anybody. I think there's, obviously constrictions, but I'm just not someone to really speak on it at the moment, just because I'm not facing them.
Okay. I get your point. So you're currently not using advanced crazy scripts, right?
I'm not using in basic scripts. I mean, I've had some conversations about where things are going and what we can do, but I'm not someone who's really bumping up against any issues myself. If Bitcoin if we put the pencils down right now, I'd be fine.
Yeah, I totally get you. But let's see what there is unseen, right? As Bastiat would say. Let's see maybe what you might be missing out on. So your use case is just hodling, right? You want to hodl your coin secure.
Yep. I
so-
want much more than that in the future. I'm just not actively kind of looking at what we're facing day to day. I just kind of look at it more long-term, 5 or 10 years, and that we'll get there. A lot of my conversations are more on that range and not so much the day-to-day technological issues. So I'm not sure what we're facing this year or what really Taproot's gonna help us break through in the next 6 months. Aside from what we just covered today, which is enormous, what we've covered so far, just around, sort of multi-sig and time lock and kind of doing things with block counts. And I think the possibilities are tremendous. I would think that, in the near term, we'd have maybe more possibilities with banking, more corporate treasury possibilities. I'm still trying to think through like how a nation state would hold Bitcoin, and if I was not so much in a democracy, but as a king, like if I was king and I had Bitcoin or I wanted to acquire Bitcoin, like how do I get myself into a multi-sig with other people? And my king of my Bitcoin and my sovereign, and maybe in a corporate treasury situation, you don't need sovereignty over, the corporate treasury from an individual standpoint. So those are some of the things I'm thinking through, but I'm not sure what we're tackling in the next couple of months or what the developers are facing.
Yeah, no, I think all really good points, right? And I think this is where really one of the beauties of these new technology lies in, that people don't even know what they're missing, right? Like Harrison Ford said, like if you would have asked what people want, they would have said faster horses, right? Nobody knew that they were actually wanting cars. And I think similar it's with Bitcoin in general, and Taproot specifically. Right? You wouldn't even be asking for all these crazy features, specifically when you're just a regular hodler, right? You just want to hodl, but unfortunately, we're running out of time, and I would love to guide you through these conclusions yourself. But maybe to sum up on some of the cool use cases specifically for a hodler, would just be that at any time you can spend your coin in a 2 or 3 multi-signature, right? That's decently secure. Now with Taproot, that's nice and efficient because it's just one single public key, right? So nobody even knows that you're using multisig. However, you might want to have that, for example, after 1 year, right, if something happens to you, your wife and your kids can spend that coin, right? So in this scenario, you want the family to spend the coin. In another scenario, right, maybe after 5 years or so, something really bad might have happened, maybe something to both you and to your family, right? And in this case, a lawyer ought to take, even in a single sig multi-sig, in a single sig wallet, the lawyer himself can take care of this, right? So you can now set up multiple layers, and specifically even a tree structure of all possible spending conditions. So instead of having in the current Bitcoin script just one line of all the spending conditions in one huge blob, what we can do now is have a modular system with each spending case being uniquely separated. And so we can have 10 different spending cases that are now not all written in one line of code with a crazy if-else statement, as Bitcoin script does it, but that are now nicely structured in a modularly. It's either the 2 of 3 just by you, or it's the 3 of 5 with your family, or it's the single sig after 5 years with your lawyer, right? All of these things are no longer together, but individually. With the nice aspect that when spending, you don't have to reveal all of these clauses, all of these potential spending conditions. You only have to reveal that spending condition that you actually used. So for example, in your case as a hodler, if you're happy and healthy and you want to buy your Lambo now, right? Not with your family and so on, just because you want the Lambo, you can do it yourself and spend these coins without ever leaking on chain that there was a fallback condition with your family and a fallback to the fallback condition with the lawyer, right? So now you as an end user can gain much more complex protection of your property rights with many more nuances in the contract, basically, a much more nuanced contract, without needing to tell everyone about the contract every time and pay the fees for that, right? So this is one of the other parts. Again, I'm sorry that we had to rush now this last step of mass so far. But John, I want to be respectful of the next speaker's time. So where are we at with the scheduling?
100%. So what I'm thinking right now is we have a half hour, depending on everyone here, their involvement. You know, Eric obviously is the next speaker, so he's going to hang around, I'm sure. If you guys are cool to keep going, we can keep going for another half hour until Eric's talk, just to kind of hash out a lot more of these practical implications of what we've talked about, because I think we've laid a really good foundation for understanding this and kind of going into some of the ramifications of this technology. Another thing that I'd like to throw out there is a potential bonus session, where we get together again with Max in the similar format, and I'd invite anyone here and potentially anyone else who wants to join, to continue the conversation, so that we're not rushed, because I think this is a very important conversation to have, and I think really beneficial for a lot of people. So I'm open to hear your guys' input. Would you guys be interested in something like that?
Yeah, definitely. I mean, I'd love to continue for a few more minutes if Max is willing now, just why we have him for sure. But that's on Max.
Oh no, I'm happy to stick around, of course. And also to repeat, I mean, I love having good conversations. I can't get enough of them. So when we got a good crew together, that's always nice.
Great. Well, yeah. Why don't we just continue for another 15 minutes or so here? Max, if you have any other questions that you'd like to kind of guide us down in a particular thought trajectory here, I have, it's getting my mind racing a lot, but I'd love to hear what particular direction you'd like to take this.
Yeah, I hope your mind is burning by now. That's always the sign of a good Socratic, when you're actually thinking. So yeah, I really wanted to talk much more about the actual entrepreneurial use cases. So maybe that's something that we can now really talk about. What problems do our clients have that Taproot solves? Specifically, let's stick with, for example, more efficient multi-signature. So how can we use multi-signature to solve problems of your clients? Eric, shoot at us. What would you think?
Yeah, I think probably one of the best use cases is for individuals to be able to enter into multi-sig contracts where no individual actually has full control over the coin. So now we can start doing things like operating a company's treasury using multi-sig, and the only way that spending can happen would be, say, if there's a quorum of individuals from the board of directors issuing a spend. In addition to like other very cool things can be done with this format too, such as say your CEO is not performing well and there's a contentious need to remove them, there would be the capacity to use this multi-sig structure to actually remove them from the ability to control the coins and to create a new quorum without them. So I think that's just scratching the surface of one thing, but one of the other ones that I'm actually much more interested is the ability to use multi-signature in these quorums in order to essentially be able to create new lending products that overlay with them with people to be able to use their Bitcoin as a form of collateral collaboratively with others. And I think that there's a lot of interesting use cases that are going to come out of that.
Yeah, I very much agree, man. I call it non-simulated non-simulated shared ownership over a scarce asset. Um, it's so ridiculously awesome that we have this, like the ability that it's like cryptographically enforced that only a group of individuals can spend money. That's so breathtakingly awesome. Because that's so far that has been the main reason for actually doing a corporation, right? For creating a legal entity, was so that multiple individuals are forced to make a decision together, right? You sign a property right contract as a company, and then you have to figure it out as this group of individuals. And now you do the same thing, but no longer with a company structure, just by private public keys, right? But you still achieve that non-simulated shared ownership, actually having the skin in the game together. But right, as Eric mentioned, this also means that you will have to get people out of the multi-signature, or that there are malicious people in this quorum. Or maybe to phrase the question more openly, how can we use multi-signatures to protect against malicious people in our business? Actually, Steve, we haven't spoken much so far. What do you think about the question? How can we use multi-sig to protect against malicious parties of a company? Are you there, Steve?
Yeah, I think Steve is my father, actually, who's joining in. He bought himself a ticket, so.
Oh, fantastic.
I don't know if he's interactive at this point. It might be just getting settled.
Okay. Well, Steve, just drop in whenever ready. But then I forward the question to Ian in the meantime. How can we use multi-sig to protect against malicious parties inside a company?
Yeah, that's interesting. Well, I guess if you can have more complex conditions supported, by doing that, then is there a way that, the conditions themselves make it so that any malicious actor couldn't actually kind of meet said conditions, and you therefore are able to detect that? I'm not sure.
Mm-hmm. Yeah, so that's actually very nice to frame it generally. You need to provide a script or contract that has spending conditions, but these spending conditions are very difficult, if not impossible, for an attacker to get right. Is that somewhat a good summary of what you said, Ian?
Yeah, exactly.
Yeah. Okay, I like that intuition, actually. That's a really nice way to looking at it, because for example, then saying that you always need two signatures instead of one signature, right? We would assume that this is more secure because for the attacker, it's easier to get one signature than it is two signatures, right?
Right.
And that's actually a nice generalized example. Herman, could you maybe elaborate on some more
Put it in
other
with
ways?
salt water.
I'm thinking that if somebody breaks into my house and I've got the other code right somewhere else, so maybe with my lawyer, with my cousin, so it's really defensive money then, because it's not worth it to break into my house.
That's very interesting, right? If the script says that you require multi-signatures, but the private keys necessary to generate these different signatures are in different places, then in order to spend, you again have the requirement to go to each of these places and visit them and do some protocol before you can actually sign.
For the government as well.
Yeah, exactly. It hinders you a bit again, right? If you want to spend your money, you actually need to, go through that whole tantrum and like fill out or fulfill all of these requirements. But of course, an attacker has as well. So physical separation is very good. Let's see, John, how much physical separation? What are the different gradients of physical separation?
You're muted, John.
So the question is, what are the different gradients of physical separation? Meaning, so I'm trying to kind of understand what you mean. Is this is this talking about like you have yeah, I'm not going to try to.
Okay, maybe let's see. There are, can you imagine different attackers where different levels of physical separation will be meaningful? Let me maybe give you one example. In the case where your attack vector is your child all of a sudden reaching your phone and making a transaction, right? And your child is always in the living room, then if you have both of your keys in the living room, right, against that adversary of the child, thick thumbing the phone and sending the Bitcoin, that would be a problem. So let's say the minimal degree of defense that you could take would to put the second phone in your office, right, somewhere high on the shelf that the kid can't reach. So then against this adversary, that physical separation is already sufficient. But can you think of other adversaries where different degrees of physical separation are needed?
Certainly. I mean, so there are people who you need to be aware of that attacks from thieves, for instance, like coming in, gaining access to your keys. So there's that vulnerability, and even the like one person having the ability to control things makes them vulnerable to extortion. And there's also, I guess, natural vulnerabilities of having of storing keys in one particular location. So geographical separation can help to have a more robust setup against that.
So in your example, if you have all your keys in one house, right, an attacker comes to this house, then you're screwed. Not just if it's a thief, but also if it's fire, or an earthquake or a flood.
Certainly.
Right. So again, here these are multiple things. Let's maybe even take it to one level larger. Let's think about physical separation on a national level. So let's see, Ian, what do you think? Like, when would it be useful to separate your keys on different continents even?
Yeah, it's interesting. I mean, I could imagine just any sort of major societal or political unrest, or this idea of just political diversification being something that could be just a useful to know that you sort of have that, and you're not fully exposed to a single geography or single kind of jurisdiction.
Yeah, right. So jurisdiction is one important aspect. As soon as you have all keys within one jurisdiction, and the attacker compromises the jurisdiction, meaning that by law you're required to do the signature, because you are in that jurisdiction, right? Then if everything is in one, then you have to make the signature with all keys, right?
Right.
But if you have, let's say, only one out of three keys in a jurisdiction that makes this that has this law, but the others are not, right? The other two keys are in some other country, then even though this one key is compromised, because the other keys are not compromised, you're still good.
Yeah, absolutely.
So here the attacker would be anyone who misuses international or national jurisdictions, but anyone who has not yet the power to misuse more than one international jurisdiction. So we are still not protected by one person who controls the one world government and gets his way in all the jurisdictions. Against that attacker, we're still not good. Is there some way that we could protect even against or with multi-sig specifically, even against that type of attacker, or are we at that point just lost and we give up?
Throwing up into outer space.
Yeah, right. I think that's the way to go too.
Well,
International waters might be.
Also time wise, like if something, bringing the element of time can help to make it so that it's not even possible to spend these transactions within 5 years. But then that also creates severe limitations for the usage of funds for entrepreneurial purposes. So I guess that's a trade-off there.
Yeah. Hey, that's a very good point worth hammering home just before we here in the finishing rounds. And that is that we don't want to lock ourselves in too much by creating too restrictive rules, right? If we make too crazy setups where we need 7 out of 15 signatures from from 5 different continents, this will take time and energy to do this. And here's again one of the cool things with Taproot. We get a more modular aspect to the scripts, meaning we don't have to reveal and use all of them, right? We can have edge cases, basically fallback conditions that will save our ass. And that can be, so for example, you have a crazy on 3 continents, you have 5 private keys and you need to get 3 of them to send. So the but if this goes wrong, you can have another clause in the Taproot tree, another modular spending condition, that after a certain timeout, only a single sig can spend this, right? So even if something goes wrong in your crazy interactive setup, because you have that fallback condition, you can still spend the Bitcoin. Now, this has both benefits and downsides, right? So where do you see both a benefit and a downside of that ability to have many fallback conditions? Herman, what do you think? Okay, how about Zed? Maybe some final words on the aspect of having different, more nuanced fallback conditions.
Well, I think it's going to open up a lot of possibilities. I think that having more options is what we're all looking for. So as the protocol provides more capabilities, then more use cases will arise. And then more things that like I don't even know I want will be either provided to me or will replace the things I'm currently doing. And that's where I think is really the big issue, is that what does Bitcoin solve for you? So right now it solves a way for me to move my time and value through space. You know, but I have all these other services like payment services or banks right now that I would love to replace, but are efficient at the moment, even though they're centralized. So as Bitcoin gets more capabilities, then it'll seamlessly replace those things for me, and I won't even realize it. It's kind of how I'm expecting it to happen, or at least for most people. They'll just use Bitcoin because it's easier. They'll store money there because it's easier. They'll send money between each other because it's easier. They'll lock it up in their corporate treasury because it's safer and there's less risk. But like you were saying before, I don't think we know what we want right now. And I think that I have the things I want and need. I just want them to be better. So when Bitcoin catches up, it'll just seamlessly replace those things for me.
Yeah, I think that's a very good way to put it. Right, that it's always good to have more options, specifically when it's opt-in. And so the entire Taproot construction is completely opt-in. You don't even have to use it at all. So that's why it's a soft fork, right? But even that, when you are still using Taproot, you can use only some benefits, like you can only rely on the multi-signature aspect and the key aggregation. Or you could even just rely on the tree structure of scripts, and use this to whatever big or small extent you want. I think there is a limit of having 32 scripts branches in the tree, if I remember it correctly. So you can have 32 simultaneous property rights definition that all define who can spend the coin, and you only have to use one of them.
How
Go ahead,
user
Sid.
friendly are these scripts right now? Are they plug and play for consumers or prosumers, or is this really people that are operating and working on Bitcoin Core and using open source projects that are in beta or just been released, kind of thing?
I think we're at a bit of a point in flux now. In general, it's still complicated as hell. There are already some tooling software out there, and specifically what I would love to mention here is Miniscript. Miniscript is a
Peter
new
Woolley's?
programming. Sorry, what?
Peter Woolley, he kind
Peter
of
Woolley.
he just released that, and it's a lot of kind of plug and play little scripts, right?
Yeah, so it's cool. Miniscript, I'm not sure if the details in my explanation here are correct, but basically it's a new programming language that comes. So we have the basic underlying Bitcoin script, which is like this huge bucket of awesome tools that you can use, but it's a bit complex and crazy. So someone wrote one layer higher and said, here's a new programming language. And it's much easier to write programs in this programming language. Because it's like, I should get an example in front of me, but no time. So there's like, you literally write pub A or pub B. This is how you would say a 1 out of 2 multi-sig. It's like a much easier syntax, basically, to write what you want, almost like in human readable form. And Miniscript, the compiler, then breaks this down into actual Bitcoin script. So it takes what you want, for example, public key 1 and public key 2, or public key 1 and public key 3 after block 5000. Like verbal, logical blocks like this, you would put in, and the Miniscript program spits out a optimal and a secure, a verifiably secure and a efficient Bitcoin script that does exactly what you want. So hopefully soon you don't have to write Bitcoin script yourself at all, but you just have to write the design in like this logical design language, that is much more approachable rather than the Bitcoin script programming language, which is fucking horrible. But hopefully when that is out, and there are already wallets that use Miniscript, the Magical Bitcoin wallet is one. There are like other already good script generators that you can really use as a layperson, just by logically thinking about who do you want to spend this money, and automatically generates a proper actual Bitcoin script.
Max, thank you so much. This has been an extremely mind expanding journey, and I found it's been just it's been very challenging to to keep to keep up with this conversation and to start to integrate these ideas, which I think is so awesome. It's such a great way to learn, as opposed to so much of the education that I've received in Bitcoin, which has been mainly just kind of like fed to me, right? So this has been a very challenging process to be actively thinking about these things and to come up with to re-express the ideas that I'm formulating, and to it's creating a whole new realm of comprehension. So I appreciate that. I think that it's a great conversation to continue. I think this calls for a Socratic session number 2. So let's try to get that on the books, and I'm going to send invites out, and hopefully we can align with everyone's schedules to go further into the ramifications of this. So I'd love to give you just a couple minutes to have any final thoughts and final words for the audience. And then after that, we can take a 5-minute break and then move to session number 5 with Eric Kaysen.
Yeah, John, man, that really summarizes exactly why I love the Socratic method and Socratic seminars. It puts you in an uncomfortable position of actually having to think like a real human. It's crazy. But no, it's like I struggle with the format myself so much. Just the aspect to ask good questions is very difficult. And of course, answering good questions is also very difficult. So I totally get that many of you were, or like that you were uncomfortable and not know exactly what to say and not exactly sure how to put it. That's exactly where you want to be. In that state of uneasiness is where you rise to grasp for meaning and for reason. And to reach that uncomfortable state where you also like with the goal of seeing your contradictions, right? When you don't understand, or when you see internal contradictions, well, I think that this is true, but I also think that this is true, but the two things cannot be true at the same time, right? All of these small logical like quirks that you realize, well, first of all, it's really annoying to realize them. It's like, hey, my brain is not working, what's going on? But as soon as you do realize it, you can start fixing it and actually connecting this properly. And this is what has helped me a lot. I mean, the Socratic method is how I learned, well, speaking English and economics, especially. Like praxeology is the Miseskreis, Mises circle is the Socratic method, right? So a lot of philosophy, there's so many very, very complex schools of thought are suitable for this type of open inquiry and conversation. And there is a thriving Bitcoin Socratic seminar community out there. I mean, like multiple all over the globe are organizing it all the time. So I love the format. I hope that you guys enjoyed it too. Sorry for putting you on the spot and putting you in an uncomfortable situation, but well, not sorry. I hope you got something valuable out of it. And I'm super happy to continue the conversation. So both here, of course, with the Cosmic Deep Dive version 2 eventually, or other events that John has planned out on the Bitcoin path. as well as with any other good opportunity that we have. So yeah, I'm really looking forward to the next conversation. Thanks a lot, everyone, for participating. Really well done. This was lovely.
All right. I hope you enjoyed that session. Thank you for listening in. And a big thank you again to Max for the in-depth discussion there. That was an extremely challenging session for me personally, and I think for some of the other attendees. But it really pushed the boundaries of our ability to comprehend the details of what exactly is going on here in the Bitcoin transaction and gain more of a technical understanding. I think that it's very important for us to continually push ourselves to comprehend more and to incorporate a deeper understanding of what's going on, instead of just taking things for granted and thinking that because we're untechnical in some way, or that we're just not a technical thinker, using that as an excuse not to think these things through. So thank you to Max. Be sure to check him out on Twitter at HillebrandMax, and check out his website, towardsliberty.com. If you like this episode, feel free to hit the like button, subscribe, and share it with anyone that you think might resonate with the message. If you want to check out more episodes, events, or learn how to support the show, be sure to visit thebitcoinpath.com. Until next time, may you live a meaningful life and enjoy your freedom as a sovereign individual.